This is Cameron Chai from ASOM, and today I'm speaking to Dave Shepherd from NETZSCH Instruments, and he's going to be telling us about their STA 449F1.
This is a simultaneous thermogravimetric analyzer differential scanning calorimeter. So we are measuring both the mass change of a material and also whether it gives off or absorbs energy. So the design of the system is we have a balance down below, and then we have a sample carrier on which we have a heat flux DSC sensor. So to make the measurements, we typically have an empty reference pan and then a pan with our sample. And then we close the furnace. And we typically will measure over a controlled temperature ramp, or also an isothermal conditions, or a combination of ramps and holds. We use this to measure the properties of materials, such things as melting points, phase transitions, glass transition temperatures, and also, of course, the mass change as you get thermal decomposition as a function of temperature, or even if it's going to oxidize, you would actually see a mass gain. We can operate over a wide range of temperatures depending on the furnace that we use. The standard furnace is this silicon carbide furnace, which runs from room temperature up to 1550 degrees Celsius. We have other furnaces that could go up to 2000 degrees or even up to 2400 degrees C. And on the low temperature range, we could go down to minus 150 degrees C up to 1000 degrees C. So we could actually measure DSC and TGA instrument measurements in one measurement from minus 150 up to 1000. We also have some special furnaces, such as this platinum furnace, for measurements of specific heat. So our instrument is very unique in that we can measure specific heat of a material with accuracy of plus or minus 3% up to 1400 degrees Celsius. And you can see we can have two furnaces mounted on an instrument. So we can extend either the temperature range or the application range by moving and selecting a particular furnace. Alternatively, we could have an automatic sample changer connected to the instrument, so we could measure up to 20 samples consecutively by having it be automatically controlled through the software. Another nice feature of the instrument is we can connect any gases that come off of the sample to a mass spectrometer, an FTIR, or a new thing for us now is connecting it to a GC mass spec. So in this instrument, the gas flow rates are upwards. Anything that comes off the sample will either be vented out to a hood, or if you have it connected up to a mass spec or an FTIR or the GC mass spec, we have a heated adapter head to prevent any condensation of material, and then from there the material is transferred over to your other measurement device by a heated transfer line. Typically for our samples, we will use, for DSC, we'll use crucibles about 85 microliters in volume. They could be of platinum. These are of alumina. They could be aluminum. It could also be graphite or other materials. And we will often put a lid on the sample to help give us the best TGA or DSC data. But there's a hole in the lid so that allows volatiles to escape. Alternatively, we could use just a large volume TGA only crucible, which would allow us to make measurements on samples with volumes up to 5 milliliters. And the balance of the instrument is such that we could measure up to a 5 gram mass change, or on another instrument we could go to a 35 gram mass change. So we can measure very large masses, and we could also measure it in very small resolution. The resolution on this instrument of the balance is 0.25 micrograms, which is 25 nanograms, which is very, very, very sensitive balance. So in summary, what we're doing is we're measuring the mass change of a sample along with the enthalpy of the sample, whether it gives off or absorbs energy, as a function of time or temperature through a very wide temperature range.
And what sort of industries typically use an instrument like this?
Well, a lot of our customers in a high temperature field use it for studying of ceramics, the sintering process, Also in metals for looking at phase transitions and melting points of metals. But also, even in the polymer industry, we can do the simultaneous DSC TGA, and we have that unique characteristic of being able to measure from -150 up to 1,000 in a single run, which if you're using separate DSC and TGA, most independent DSC instruments only go up to about 600 or 700 degrees Celsius.
All right, and if anybody wants more information about the STA 449F1, they can go to your website.
We can go to our website, NETZSCH-thermal-analysis.com is our international website. They can download brochures, they can download applications papers, and of course they can send requests to us for more information.
Fantastic. All right then, Dave, thanks very much for telling us about your thermal analyzer.
You're welcome, Cameron.